Have you ever looked at the graph and you thought that this graph doesn't signify anything? It happens sometimes when you are using a standard linear scale for the graph, because the linear scale will suppress some of the information when the range of magnitude is very large. But what if there is a way to reveal those information and have a clear visual of your data that we are looking at? And the solution to this problem is logarithmic plot. Basically, it is very useful when the data covers a wide range of values, or we can say a large variation in magnitude of data. In this type of plot, a linear scale does not play a significant role, but a logarithmic plot can give you a significant clear visuals about your data. So now we are going to understand why logarithmic plots are important and how you can plot those things in MATLAB. So let's get started. Just imagine that you are a seismologist and trying to develop a relation between the earthquake and the amount of energy releases by it. You have collected a set of data on earthquake ranging from, let's say, 1 to 9 and the energy that releases, and the readings are this. And here you can see all this data carries a large range of magnitude. When the magnitude is 1, the energy is 6.3 into 10 raised to 5. And when the magnitude is 9, the energy is 6.3 into 10 raised to 17. So see the vast difference between the scale 1 and scale 9. So here first we are going to plot a simple linear graph. So here we are going to create a simple linear graph between magnitude and energy. And this line will create a grid on the graph. It will give the title to the graph, X label and Y label. And now let's run. You can see here for this range of magnitude, the energy releases by earthquake is not being properly represented in the graph. So this is what the problem happens with the linear scale, and that is what I was talking about earlier. Now instead of this linear scale, we are going to plot a logarithmic scale, and then you will be able to find the difference between linear scale and logarithmic scale. So now let's plot a logarithmic scale. We are going to use the same data to plot the logarithmic scale. There are basically 3 functions to create a logarithmic graph in MATLAB. The first is semilog x, the second is semilog y, and the third is log. In this section, first we are going to use semilog y, and then we'll go for semilog x, and then we'll go for log. So here we'll go for semilog y, and then we are going to copy this because we are going to plot the same magnitude versus energies graph, right? And then we'll use the same commands grid on to give title, X label and Y label. A small modification we'll do here because it is not the linear scale, it is the logarithmic scale. And now we are going to run this thing. So here you can see this is the logarithmic graph. You can clearly see the difference when the magnitude is in between 1 to 6. A proper variation in energy releases can be observed through this graph. Now let me combine this linear scale and logarithmic scale and give you a proper visual effect that what is the clear difference between the linear scale and logarithmic scale. So this is the script where I have combined both the graph. Here in this section I am defining my magnitude and energy, and here in this section I am creating a linear graph. This is the command subplot using which I am going to combine 2 graphs in one figure. Right, so it's a linear graph plotting, and here I am plotting a logarithmic graph, and this section is just to give a title and proper positioning to both the graph. So now let's run this section, and here you can observe the difference between the linear scale and logarithmic scale. When the magnitude is from 1 to 6, you cannot see any changes in the energy scale. But in logarithmic scale, when the magnitude is from 1 to 6, you can see significant difference into the energy scale. So it is not suppressing any information into the graph, whereas linear scale suppresses the information into the graph. Now here in this example, we have understood it using semilog y. That means we are using logarithmic function in y scale. But what if I want a logarithmic function on x scale? So now let me modify this code for logarithmic function on x axis. So I'll just copy this entire code, and instead of this samilog y, what I'll do, I'll use samilog x. Just run this thing and we can have logarithmic scale on x axis. But here in our example, if you use logarithmic scale on x-axis, your problem will not be solved. Why? Because for our example, the data variation is on energy scale and energy scale is on y-axis. So when the data variation is large, when the magnitude is large on y-axis, you should go for logarithmic scale on y-axis. Instead of y, if the data variation is on x-axis, the large data is on x-axis, then you should go for the logarithmic x or logarithmic function on x-axis. But now, what if both the axes have the large variation of data? In that case, you should go for x-axis as well as y-axis, both the axes on logarithmic scale. So how to achieve that? Now we are going to learn that thing. So we are going to copy and paste the same code, but instead of samilog y, we are going to use log. This log function will plot logarithmic graph on x-axis as well as y-axis. Now let's run this thing, and you can see on x-axis we have logarithmic scale. The same way on y-axis also we have the logarithmic scale. So that's how you can plot a logarithmic graph on MATLAB.